Chapter 5, Section 6, we're going to learn about inverse functions. So an inverse function, we know that the inverse of addition is subtraction, the inverse of multiplication is division. So it's just like the opposite of what our function is. So if we look at these two charts here, we have our original function 2x plus 3. Our inverse has the opposite operations happening to it, and also our x's and y's flip. So if we notice, we go from x is negative 2 and y is negative 1 to x be negative 1 and y is negative 2. So all of our x and y values just flip. So our graph also flips on the x is equal to y axis, so here. So our graph just flips along this axis. So we're going to jump right into our first example. We're going to find the inverse of a linear function. So f of x is just a fancy way of saying y. So this is y is equal to 3x minus 1. To find the inverse, we just switch our x and y, and then we solve for y. So I'm going to change this to x is equal to 3y minus 1. So all I did was change my x to be y and my y to be x. And now I just need to solve for y. So what should I do first to solve for y? How do I get that y all by itself? Add 1 on both sides. So I have x plus 1 is equal to 3y. What's next? Divide both sides by 3. So I get y is equal to x plus 1 over 3. And this is my inverse function. To show that it's the inverse, we just put a little negative 1 up top. So this just indicates that it's the inverse. We could also see the inverse. Since we started with f of x, we could call our inverse g of x. Which, again, it's just the same thing as y. It's just like a name for your function. So you could see it either way, like this. But they're the same thing, the inverse. So let's look at number 4. First thing we want to do, change our f of x to be y. And then we just flip our x and y. So y becomes x and x becomes y. And then we just solve for y. So what do we have to do first to get that y all by itself? Divide by 2. So we get y is equal to x over 2. We have the y all by itself, so we're done. So this is our inverse of y is equal to x over 2. All right, 5. Change our f of x to be y. What do we do next? Switch the x and y. So we have x is equal to negative y plus 1. Now how do we solve for y? Subtract 1. So x minus 1 is equal to negative y. What do we do next? Divide by negative 1. So we're dividing everything by negative 1. That gives us y is equal to what? How do we simplify that? X minus 1 divided by negative 1. Awesome. We just flipped the sign, so it's negative x plus 1. So since we have y all by itself, this is our inverse. All right, number 6. What do we do first? Switch them. So this is y. Just switch our x and y. So we have x is equal to 1/3 y minus 2. We need to get y by itself, so what should we do? Add 2. So we have x plus 2 is equal to 1/3 y. What do we do next? Divide by 1/3, but what's the same thing as dividing by 1/3? Multiply by 3. So I'm just going to multiply everything by 3. So this cancels. I have y is equal to 3x plus 6. Y is all by itself, so this is our inverse. Any questions? All right, we're doing the same thing here. All we need to do is find the inverse. I know this says determine whether the inverse of f is a function. We don't have to worry about that. Same thing with the homework for the questions that say determine whether it's a function. We're going to skip that for now, just we're finding the inverse. So we flip our x and y. So x is equal to 2y cubed plus 1. What should we do first? Subtract 1 on both sides. So x minus 1 is equal to 2y cubed. What's next? Divide by 2. So x minus 1 over 2 is equal to y cubed. What do we do next? Awesome, take the cubed root. So that cancels. So we have the cubed root of x minus 1 over 2 is equal to y. We have y by itself, so this is our inverse. All right, example 5. Doing the same thing. Switch our x and y. So we have x is equal to 2 square root y minus 3. What do we have to do first? Bless you. Awesome. We have to divide by 2 because we can't touch that square root yet until we get rid of the 2. So we have to divide by 2 first. So we have x over 2 is equal to the square root of y minus 3. What can we do next? Square both sides. So this cancels. We have y minus 3. We have x over 2 squared. Any way we can make that look a little bit prettier? Can we square x and square 2? So this would be x squared over, what's 2 squared? 4. So just a little bit nicer. And then what do we do last? Add 3. So x squared plus 3 over 4. Oops, 3 is not over 4. So it's x squared over 4 plus 3 is equal to the inverse. It'll give us a function or 2 functions, and we have to verify if they're inverses. So the way we verify is we take our g of x function and we plug it into x. My pencil worked. plug it into x of our f function. So we take that whole g of x and plug it into our x and the f of x. So we have 3 times this whole thing, so x plus 1 over 3 minus 1. Our goal is to get all of this to be equal to x. We just want x at the end. So let's simplify this. What can we do? Anything cancels out?
Yeah.
The 3's cancel out because we have 3 being multiplied and 3 being divided, so they cancel. So we have x plus 1 minus 1. The plus 1 and minus 1 cancel, so we're just left with x. So when we are just left with x, they are inverses. So that's how we verify. Just take your g of x, plug it into the x and the f of x, and you want to get x left over. If we get anything other than just x, they're not inverses. Bless you. All right, last slide, yay. So number 10, what should we do? Awesome. Take our g of x, plug it into the x of f of x. So we have x minus 5 plus 5. When we simplify, what does this equal? X. The minus 5 and plus 5 cancel, so we're just left with x. So are they inverses? Yep. Any questions on that one? All right, let's go to 11. What do we do first? So we take our g of x and plug it into the x and our f of x. We have 8 times the cubed root of 2x cubed. Anything cancel? The cubed root and the cubed, so we have 8 times 2x. What's 8 times 2x? 16x. Can't simplify anymore. Are these inverses of each other? Nope, because we have 16x and it's not just x, so these are not inverses.